In order traversal, we will be exploring first the left tree or the left subtree, I'll say, the parent, and then the right tree. So our traversal for this tree will look like something like this. Let's say we have this tree 4, 5, 6, and 7. So first we will be exploring the left tree. So this will be like 2, 4, 5. We will have 1 then we will have the right tree 3, 6, and 7. This process will similarly be repeated to these trees as well. In this also we will be going first left 4, then the tree, then the parent 2, then 5. Then we will have 1 right here. Here also we will be going first left, then parent, then right. So this will be our traversal sequence. Similarly, in the pre-order, we will first be exploring the parent, then the left tree, then the right tree. And in the post-order, we will be exploring first the left tree, then the right tree, and then at last we will be exploring the parent node. So let me write you the code for the in-order traversal. Let's say public void in order. I will be explaining the recursive way. We will take in the root node as the argument. So the sequence we will follow is like, first we will be exploring the left node, then the parent, and then the right node for in-order traversal. And let's talk about the base case. If we hit the last element, and if we go beyond this, if we go left to it, then we will have null. So when we reach null, we will simply return our value, return our answer, or return from the iteration. Our base case will be like, if root equal to null, then we will simply return. But if, let's say, if we are at the root node, then we have to explore the left node, the left subtree first. So it will be like in order root dot left. Since we know that recursion is for breaking a bigger problem into smaller problems, so we are breaking a bigger problem into smaller problem. We have to traverse the whole tree. So we will do it like in order that we will break the problem into this tree, and we have the parent and then the right tree. So here we are doing the same thing. We are passing it that the left here we are passing in the argument the left tree, and we will be printing. I'll say system.out.println system.out.println root dot val, because we have explored this way. By this line we should have some faith. By this line we should have the faith that we have explored the left subtree, and since we have gone to the parent, we will simply print it on, and then we will move on to the right subtree in order root dot right. So this will be the complete function how to iterate in order way on a particular binary tree. So let me create a tree and dry run the same thing on that. Let's say we have the tree 1, 2, 3, 4, 5, 6, 7, then null, 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 and all the null values. So we will pass on our root element as the argument right here. So it will first check that root is not null. So this gets false condition, so it is shift to this statement. So it will then call root in order root dot left. So let's see it with the example. Here we are passing root node 1. Then it will go to the first statement is root dot left. It will go to the left node. This is not null. Then it will again go to the left node. It is go to 4. Now this is null. So if we are null, then it will simply return the value, and it on returns, and then this statement completely means that this statement has been executed. So this statement will execute now. Now it will be writing the root dot val. It will print the root dot val. So we will get 4 as our value, and then this call is returned. After that, again the right root node will be executed. It will be printing. After that it will be printing the second node, because this is left, parent, right. This will be the order of execution. So it will be printing 2, then 5. Then this all the tree has returned. Then it will be printing 1, then it will go to the right node. Right node, it will go to the left. Here we will be printing 6, then 3, and then 7. And in this way we will find out the in order traversal for our particular binary tree. And keep one thing in mind: if we were using recursion, have faith that this problem will be solved. Like here we would have faith that the left subtree will be returned from this particular from this call, the right subtree will be returned from this call, and in this way we will be dealing with this tree. Similarly, let's say let me tell you how to find the height of a binary tree. Height of a binary tree. See, the height of a binary tree is nothing but the maximum distance between the root node and the null node. Let's say, for example, this is our tree. So the height of this tree will be 1, 2, 3. So height of the tree is can be determined by the maximum height of the left or the right tree. In the left we have height 1 and 2. In the right we have the height 1, 2, 3. So the height will be maximum of left height and right height. It will be the maximum of left height and right height. So we will solve this problem like the same as well. Just we will be, let's say we have a function called public int height, and we will be taking the node root as the argument, and we will add the edge case, like if the root is equal to null, we will just return, but else we will be finding the left height. I'll say left height is equal to height, and we will pass root dot left. Similarly, we will be having right height, and we will be passing root dot right. Now we have the left height and the right height, and the answer is that the maximum of left height and right height plus the 1 is for height of the root node. So we will be returning math.max of left height, right height plus 1. So by this way we will be finding the answer to our answer of height of our binary tree. Let me give you a brief how this will be found. Let's say we have the tree like this. We have to find the height of this tree. So we will be finding the height of this subtree and this subtree, and whichever is and the height of whichever tree is more, we will add 1 to the height of that tree. 1 is for this particular root node, height of this plus 1, and that will be the complete height of the tree.